Good morning everyone. Today we will discuss one of the important topic, that is transformation star to delta. Okay, we'll solve some numerical. This lecture is based on numerical only. We'll try to solve within 2 minutes. Okay, so let's start. So the numerical is based on actually the delta network, star network, and we'll convert it into delta. Okay, so first we'll see the numerical. Okay, the question is find the equivalent delta network of the given circuit. Okay, so this one is a star circuit which here is given, so we'll convert it into delta network. Okay, so here the question is given, the value of R1 is 6 ohm, value of R2 is 3 ohm, and R3 is 9 ohm. So we'll try to convert it into delta. Okay, so first see what is delta network. We know this one is the star network. Okay, this is looks like a star, but this one is the delta. Okay, so this we want to convert from star to delta. Okay, so first we will see what is the value of R1, R2 and R3 given. R1 is 6 ohm, R2 is 3 ohm, and R3 is 9 ohm. Now we should find out the value of R12, okay, R13 and R23. Okay, so before finding, see this one is the 1, this one is the 2, and this one is the 3 terminal. Okay, so now this is similar case. So R12 means resistance between terminal 1 and 2. Resistance between terminal 1 and resistance between terminal 2. So whenever we are trying to move from this way, okay, so first resistance is 6 ohm, second resistance is 3 ohm, and there is another connection is there. Okay, so the R12 is R1 this resistance plus R2 this resistance, and this R1 R2 divided by R3. So this is the third term related to this particular thing, we can say. Okay, so R12, how simple, R1 plus R2 plus R1 into R2 divided by R3. In this way also we can remember, first we will write R1, okay, then R2 plus R1 into R2 divided by R3. Okay, so the value is given, R1 equal to 6 ohm, R2 equal to 3 ohm, and R3 equal to 9 ohm. Okay, so we can write R1 equal to 6, R2 equal to 3, and R1 R2 divided by R3 equal to 6 into 3 divided by 9. Okay, so the answer is 6 plus 3 9, 6 into 3 18 divided by 9, so there we'll get 2. So this whole term we are getting 2. So the answer is 6 plus 3 plus 2 equal to 11 ohm. Okay, now moving to the next point. Next we are calculating the value of R13. So R13 equal to R1 plus R3 plus R1 R3 divided by R2. So this one is the R1 plus R3. See, R1 plus R3 plus R1 R3 divided by 2. Okay, so first now we are calculating the resistance between terminal 1 and 3. Okay, so 1 and 2, what are the resistance are there? So first we will see, we can write 6 plus 9 plus 6 into 9 divided by 3. Okay, so 6 plus 9 plus 6 into 9. So R1 is 6, R2 equal to 9, and this one 6 into 9 divided by 3. So we are getting 15 plus 18. So total, so this term we are getting 3 into 3, 9. So 3 cross 3, 6, 18. Okay, so we are getting 18 plus 15 equal to 33 ohm. Okay, so similarly we can calculate the value of R23. So whenever we are calculating the value of R23, so we will get R2 plus R3 plus R2 R3 divided by R1. Okay, so we will write down R2 plus R3 plus R2 R3 divided by R1. Okay, so what is the value of R2? R2 is 3 ohm, R3 is 9 ohm, and R2 R3 means 3 into 9 divided by R1 equal to 6 ohm. So we can write down 3 plus 9 plus 3 into 9 divided by 6. So we are getting 12. 3 plus 9, what is the value? 12. 3 into 9, 27 divided by 6 equal to 4.5. So we are getting 12 plus 14.5, 16.5 ohm. So this is the equivalent delta network of the given circuit. Okay, so simple technique, within 2 minutes already we solve this problem. Okay, so first the value will be given R1, R2, R3. So we should calculate the value of R12, R13 and R23. Okay, so R12 means resistance between terminal 1 and 2. Okay, so whenever we will calculate R1 plus R2 plus R1 R2 divided by R3. Similarly, R13 means R1 plus R3 plus R1 R3 divided by R2. R23 means R2 plus R3 plus R2 R3 divided by R1. So this way we can solve our simple numerical of the star to delta conversion. Okay, so similar we will solve another problem based on this. So this is the network given. Here R1 value is different. R1 is 4 ohm, R2 is 8 and R3 is 12 ohm. Now we will find out the value. Okay, now we will convert this network to equivalent delta network. Okay, so we will find out the value of R12, we will find out the value of R13 and we will find out the value of R23. Okay, so R12 simple. R12 means R1 plus R2 plus R1 into R2 divided by R3. Okay, so first we will see the value of R12. Okay, so R12 means R1 plus R2 plus R1 R2 divided by R3. Okay, so see here R1 plus R2 plus R1 R2 divided by R3. Now we will write R1 value is 4 ohm plus 8 ohm plus 4 into 8 divided by 12. So we are getting answer is 14.66 ohm. 4 plus 8 means 12. Okay, so here we are getting 8 divided by 3, 4 into 3. So this 8 by 3 equal to 2.66 ohm. So we are getting 14.66 ohm. Now similarly R13 equal to R1 plus R3 plus R1 R3 divided by R2. So we can write down R1 equal to 4 ohm, R3 equal to 12 ohm plus 4 into 12 divided by 8. So we are getting answer is 4 plus 12 means 16 plus 6 22 ohm. So we are getting R13 equal to 22 ohm. See, R13 is this value. Okay, so R1 plus R3 plus R1 R3 divided by R3. Okay, similarly we can calculate the value of R23. R23 is R2 plus R3 plus R2 R3 divided by R1. So what is the value of R2? R2 is 8 ohm, R3 is 12 ohm, or R2 to 8 plus 12 divided by 4. So 8 in plus 12 plus 8 into 12 divided by 4. So we are getting answer is 8 plus 12 is 20 and this one 4 2 times, so 24. 20 plus 24, the answer is 44. Okay, so simple calculation, we are solving delta network, okay, from the given star network. Okay, so this is the simple numerical. Another lecture will solve vice versa, means we will solve from delta to star network and also some complex problem. So thank you everyone, thank you for today.